Welcome to the new lecture. In this lecture, we are going to discuss about the mapping cardinalities in ER diagram. It is the most important lecture. So, in order to solve any problem, in order to convert the ER diagram to the table relations, we should have an understanding of these cardinalities. It's the most important one, right? And in the previous lecture, we have studied about the degrees of relationship. Please look over the lecture, right? So, what are mapping cardinalities, right? So, normally in the previous lecture while we are studying, we have a relationships. For the relationship we have the entities, right? So for a relation we are going to have a relationship, and for a relationship we are associated entities. We have associated entities. Now we are there are many, for a business there will be many constraints, many conditions. So such conditions, if you want to represent, if you want to say those conditions in the ER diagrams, then there is a need of key constraints. So key constraints are those which allow to give some properties for data in ER model. So by these key constraints we are going to give some properties. This is most interesting. We are going to give some properties. So by the properties we are going to identify what type of relationship is between the entities, right? So mapping cardinalities are one type of key constraints. So key constraints give us these particular features to give some properties to the data in the ER model, and mapping cardinalities are one such key constraints which define the maximum number of relationship instance in which an entity can participate, right? So we have going to have every entity have some values from tuples, right? So how they are going to interfere, how they are going to have the relationship with the other entity, the relationship instances are going to be specified by what? By the mapping cardinalities. You will get a better understanding when we go for the examples, right? So cardinality defines the relationship instances in which an entity can participate. Now this type of cardinality relationships are classified into four types. The most important ones are these four, that is many to many cardinality constraint, many to one, one to many, and one to one. Let us go those things, do this about four in a separate one by one. You will be getting a better understanding of it, right? So let's start with many to many cardinality constraint. So many to many cardinality, it is going to specified in m is to n, right? So here we have a relationship, right? So here we have two entities. Now normally a many to many is going to specified by a normal line, that is we are not going to have any arrows. So in the different, if we have one, we are going to have an arrow, right? So in it is the symbols, right? So in this particular relationship we have two entities. So what are the conditions which hold when we have the many to many cardinality? Let's look over them. An entity in set A can be associated with any number of entities in set B, right? So the entities in set A can be associated with any number of entities in set B. In the same way, an entity in set B can be associated with any number of entities in set A. So it is many to many. Let us look at an example. See here, here we have two entities, student and course, and one relationship enrolling. So we have attributes. I have not specified any attributes here for simplicity. See here, a student enrolls in course. Student is going to have the ID, student ID, student name, student age, and course is going to have the course ID, course name. I have not indicated for the simplicity, right? So let's understand about the cardinality, right? So student enroll in course. Now here we have a simple line. We doesn't have any arrow. If it doesn't have any arrow, it means that we have which type of relationship? Many to many relationship. That is, if it doesn't have any arrow, we'll be having arrows, right? We are going to specify the specify the arrow. So here we doesn't have any arrow, means it is many to many relationship. So in such relationship we can have we can signify some properties here. What properties we can signify? Suppose if I name, I have a student S1, I have a student S2, and I have a student S3, and same likewise I have students up to S100, and in the same way I have the course 1, I have course 2, course 3, course 4 up to course 10, right? So now here the relationship is many to many. Now a student is going to join the course. Now a student S1, if a particular case, if I take student S1 can join the course C1, right? So here many to many means one student can join many courses, right? Once S1 can join C1 course, and the same S1 can join the C2 course, and the same S1 can join the C3 course, because we have specified what type of relationship between them, many to many. That is, here one student can join many courses, right? So in the same way, here the indication, see here what type of indication from this side is there. One course can have many number of students, right? In the course C1 I can have S1, I can have S2, I can have S3, that is I can have many students indicated in a single course, right? So such type of relationship we call it as what? Many to many cardinality, right? So here the points we have laid here is a student can enroll in any number of courses, so a student can join in any number of courses, because many to many relationship. In the same way, what is the other point? From this side we have identified many, it's from this side also many. So what we have identified? A course can be enrolled by any number of students, any number means 0 or more, right? So this is a many to many relationship. So what we have in the many to many relationship, let's look over here. An entity in set A can be associated with any number of entities in set B. See here this is the entity set student. Every S1, S2, S3, all this we called as what? Entity. This is an entity set. S1, S2, S3 we called as what? Entity. Now an entity in set A can associated with any number of entities in set B in the many to many cardinality ratio. In the same way, an entity in set B can be associated with any number of entities in set A, like C1 can have S1, S2, S3, like so, right? So this is about many to many cardinality, right? So we have discussed about the many to many cardinalities, right? Let us discuss about the many to one cardinality. By this you will be getting some clarity here. If you observe the difference between the many to many and many to one, you will be getting a very good clarity. So in the many to one cardinality, an entity in set A can be associated with at most one entity in set B. See here in the previous case, in many to many, it can associated with many entities. Now many to one, it is the reason we have set A can be associated with at most one entity in set B, right? So but many to one, this side one, but this side we have what? We have many. So from set B to set A, see here, an entity in set B can be associated with any number of entities in set A. So set B can associate with any number of entities with the set A, whereas set A can associate with at most one entity in set B, right? See here in the symbols here we have two entities A, B. Now the relationship R. See here in the many to many we have used a single line, but here where we here many to many we have used a single line. Here many to one, where we have the one, we should use the arrow, right? This is one way of representation, right? And also we can specify in the other way also. So we can, if we can specify the arrow here, the end or here also, you can specify here or also here. So this relationship like this specifying this called what? Many to one. It is called what? Many to one. Let us look at an example. So let us take the same example, right? So it is a many to one cardinality. So here it is a many, right? So here one we can we are going to specify with the arrow mark. We can specify the arrow here or also, or else we can specify here also, right? So what does this mean? So it is what? It is many to one relationship, right? Now let us take here, suppose I have student entities S1, S2 up to S100, right? As if we have taken previously, we have courses from C1 to C10, right? C1 to C10. Now these S1 to S100 are the entities of this entity set student. In the same way, C1 to C10 are the entities of the entity set course. So what is the condition here? An entity in set A can be associated with at most one entity in set B. So entity in set A is what? S1 to S100. So S1 can associated with how many entities in set B? Only one entity. Means what? S1 can, if S1 is related to C1, then he can't relate to the C2, right? Have you understood the point? So if S1 is related to the C1, S1 cannot take C2. That is the condition. So many to one, that is, if an entity in set A can be associated with at most one entity in set B. That is, if S1 takes the course C1, then S1 cannot take the course C2. That is, it can enroll with only one. So that is many to one. Now this side we have many. That is, a course can have many number of students. That is, C1 can have S1, S2, S3, S4. It can have many number of students. But whereas this side, from this side, S1, an entity in set A can be associated with at most one entity in set B. That is, S1 if it goes to a C1, then he cannot take the C2. It can be the other case. If S2 joins the course C1, S2 if it joins C1, he cannot go to the another course C2, right? So such conditions we can easily represented with many to one cardinality, and that is the beauty of this key constraints in ER diagram, right? So what we have learned is one student can enroll in at most one course, in the same way what we have learned, one course can be enrolled by any number of students, so any number means 0 or more, right? So this is the beauty, right? So many to many, so let us just understand the difference between the many to many and many to one. In the many to many relationship, we have a dash, a single line, there is no arrows. When we have no arrows, a student can take many courses. He can take C1 course, he can take C2 course, he can take the C3 course, he can take many courses. Likewise, courses can have many students, right? But what is here? Many to one. When we have this particular arrow mark, we call it as a 1. When we have the many to 1, then a student can take a single course. So how easily we can represent the particular business constraints in ER diagrams? It's very easy way, right? So this is the beauty of ER models, right? So next we have discussed about the many to one cardinality, right? So next let us discuss about the one to many, right? So in the one to many cardinality, so an entity in set A can be associated with any number of entities in set B. Here an entity in set A can be associated with any number of entities in set B. So it is 1 to n. So it is 1 to n. So from here to here, what type of n relationship? That is, entity in set A can be associated with many number of entities because we have n. But the reverse case, an entity in set B can be associated with only one entity in set A, right? So where we have one, what we are going to do, we are going to represent with the arrow mark. So it can be represented in this way also, we can represent in this way, right? So let us take an example, and by the example let us study this. So here is our example, and here it is one to many. So let us signify an arrow mark. It is one and it is the many, right? So now here one student can enroll in any number of courses, right? It's like, let us take the like previous example. Suppose this particular entity said we have entities S1, S2 up to S100, right? So we have the courses entities C1, C2 to C10, all right? So in this case, now S1 is an entity. Now what is here? An entity in set A can be associated with at most with any number of entities in set B, with any number, right? It is, here we have 1, here we have n. So we can have this S1 can join C1 and S1 can join C2, because what type of relationship we have with this side? We have n, many relationship here. So S1 can join C1, S1 can join C2, S1 can join C3, S1 can join any number of courses, right? So a student can join any number of courses. While if we come this side, see here, one course can be enrolled by at most one student. That is, for every single course, how many students are going to be there? Only one. That is, it's not applicable to the practically, because a course cannot run with a single student, right? But we can specify these particular principles in this manner. If it is one to many, an entity in set A can be associated with any number of entities in set B. If it is one to many, an entity in set A can be associated with any number of entities in set B, and the entities in set B can be associated with at most one entity. That is, only at most one entity it can be associated. At most means, if it have associated, it should have associated with one. If it doesn't have associate, it's not a problem. If it associate, it should be associated with only one, right? So we call it as a at most, right? So here what we have came to know about with this ER diagram is, one student can enroll in any number of courses, right? This is the first, 1 to n. That is, one student can enroll in any number of courses. What is the other case? One course can be enrolled by at most one student. So one course can be enrolled by at most one student. So in one to many cardinality, an entity in set A can be associated with any number of entities in set B. An entity in set A can be associated with any number of entities in set B, whereas the entities in set B can be associated with at most one entity in set A. We can represent it with the arrow 1 to n, or also we can represent here the arrow, or we can represent the end over here, the particular relationship, right? And we have studied about the one to many cardinality, and next we are going to study about the one to one cardinality. So it's the most interesting. Wherever we have the one, we have the relationship constraints there. The key constraints are playing a role, right? So next, let's study about the one to one cardinality constraint. So in one to one cardinality constraint, an entity in set A can be associated with at most one entity in set B, and an entity in set B can be associated with at most one entity in set A. See here how we are representing. It is one to one on both sides, so we are using arrows on the both sides. Oh, it can also be specified like this. So we can use the arrows. So this particular arrow we can specify here, and this particular arrow we can specify here, right? So let us take an example. So this is the example here. Now this is a case of one to one. So we have to represent. We are going to represent with a diagram representation of one to one. So this is a representation one on the both sides. Now let us understand this here. It is one to one relationship. Now S1 we have here, we can have entities S1, S2 up to S100, and the same way we can have courses C1, C2 up to C10. Now what we are going to learn here is an entity in set A can be associated with at most one entity in set B. That is, at most one. That if S1 can take only one course, if it takes C1, it cannot take C2. Right? Now this side also one. So what will be here? An entity in set B can be associated with at most one entity in set A. That is, if C1 has one student S1 only, right, it can have at most one, right? So such type of principles can be established by this one to one cardinality, right? So what we have learned here is a student can enroll in at most one course, and in the same way a course can be enrolled by at most one student, right? At most one student. So this is the key constraint condition, cardinality constant, which we have established. So it is called one to one. If it is one to one, an entity in entity set can participate with at most one entity in the other set. So is here side also one, so it have participated in at most one. So this is about one to one. So in this lecture we have discussed about all type of cardinality relationship, mapping cardinality relationship. It has been become a long lecture, but it's most important we have discussed each and every point in detail, right? Thank you.